So I'm not presenting on my own research. This is actually an honours project that was produced by a student. It's based on some monitoring work that Wildlife Act has been doing in HIP of cheetah since 2010. But the student was Olive Haig. Unfortunately, she can't be here today. She's from Bournemouth University in the UK. But this project is based on a project that Wildlife Act actually registered with Ezemvelo in 2010. And the idea was to carry out a camera trap survey and monitoring of the cheetah population in Hluhluwe-Mfolozi Park, which we will refer to from here on out as HIP. The intention of our project was to establish population densities for HIP, population densities across various areas within HIP, the population demographics, and to develop an identikit to determine individual movements, survival rates, and ultimately to work towards a more accurate population estimate. Between 1966 and 1969, 64 cheetah individuals were introduced. And in 2010, the HIP population was actually considered large and stable by management. So the monitoring that we undertook was incidental. We put up camera traps at known cheetah scent marking sites where sightings had been reported. So bear in mind that there was a little bit of a concern about bias when we first started these analyses. The other component of the monitoring was that we had full-time species monitors, and they responded as soon as they had any reports of sightings. So as I said, it was very highly incidental. Between 2012 and 2016, 333 camera trap images of cheetah were captured, and monitors recorded 400 sightings of different individuals. On the right, you can see one of the camera trap images of one of the cheetah. That's kind of a classic scene that we have in the camera trap imagery of a cheetah moving around a scent marking tree. The first collars were actually fitted in 2016 through donor funding. We fitted one male and two females with collars. These were GPS tracking collars that also had VHF capabilities. And both of these females actually died shortly after while they were denning, and we suspect it was lions. A third female was collared shortly thereafter in 2017, and we are actually in the process of trying to collar another female as we speak. Between 2010 and 2017, a total of 42 cheetah were identified. So our identikits comprised 42 different individuals, 18 adult females, 9 adult males, and 15 cubs that were all identified through the monitoring efforts. But we did pick up low survival rates. As at the 30th of September, the HIP cheetah population is 3, 1 adult male and 2 adult females. The reasons for the low survival rates are unclear, but there are some suspicions around competitors. And then the table at the bottom, it's not very, very clear, but what we've looked at, because we didn't have a very good idea of the population number to begin with, we're working on basically deaths per year. We know, for example, in 2010 we lost 4, in 2011 we lost 6, 2012 we lost another 6, 2014 1, 2015 we lost 16 that we know of. In 2016 we lost 6, and in 2017 we lost 1 individual. And so, based on the data that we had collected, Olive Haig came on board, and she carried out just a very preliminary analysis of the historical camera trap data and the small amount of collar data that we had so far to determine cheetah distribution patterns, cheetah habitat utilization and preference, and what overlap, if any, there was with competitor habitat use, and if there's any indication of competitor avoidance. As I said, it was an honours level project, so the stats aren't terribly sophisticated. She didn't, delve too deeply, but there is currently a PhD project underway to interrogate the cheetah population and the recent introductions, and going forward, what happens with the cheetah population. That's Christina Valens. So very briefly, our methodology: cheetah camera trap records and sightings were used between 2010 and 2016. We had cheetah collar data for one female, we call CF7, she's pictured at the top, from May 2016 to January 2017, and one male pictured at the bottom, who we call CM19, and that was July 2016 to January 2017. We have lion collar data for 5 prides from May to July 2016. And those line collars were giving us 4 location points per day at 6 hourly intervals. We've got some lion and spotted hyena camera trap records, which are actually incidental, also at the camera trap sites that we had out for cheetah. Those were collected between 2014 and 2016. And then a vegetation classification map for Sheffield and Flowsy Parks. All of the other data was overlaid over the vegetation map. There's an image of what that vegetation structure map looks like. It's more of a habitat type structure map than a vegetation map. On the right, you can see how our camera traps were distributed within the various vegetation structures. What's immediately obvious there is that the majority of our camera traps were in fine-leaved woodland. That's because that was where the majority of our sightings were, and the majority of the active cheetah scent marking trees were located. So again, bear in mind that little bias in the back of your minds. We do deal with it later on. In terms of data analysis, home range and habitat preference of the collared cheetah and lions were calculated using the ADE habitat package in R, and a kernel density home range analysis tool in ArcGIS was used. The analysis of competitor habitat preference, we used camera trap data for lions and hyenas and analyzed them by completing non-parametric chi-squared tests. And the idea there is it calculates the expected frequency against the observed frequency for each species in each habitat structure, which was picked up on the camera images. And then ArcGIS was used to look at habitat at each camera location and each collar location. So home range, the 95% home range size for both collared individuals was actually very similar. This is based on the collar data. It's just a pure plot of location points for the 2 cheetah, the CF7 and CM19. And if we ran home range analyses, you can see the core areas within the home range of female CF7 on the top, the red core, red and yellow. There are some, it's not very clear to see where's the pointer there. There are some green patches there and there that they were also obviously, or she was also utilizing, as well as this area here. But you can see that her home range was 95% home range, 465.9 square kilometers. Too many numbers. That was a low blow. If we look at the core area within the home range of CM19, the male, his core home range actually overlaps with the female. There's also some green patches there and a couple of green patches up there. And his 95% utilization was 450.36 square kilometers, so not too different. If we look at the number of GPS collar locations of each individual within the various habitat structures, you can see fine-leaf woodland features quite highly. And remember, this is the collar data, so it actually backs up the camera trap placement. The collar seems to indicate that the camera traps were, in fact, areas that they were utilizing most frequently. And you can see that both male and female were using the fine-leafed woodland most frequently. So, as I said here, the effects of bias on the camera trap location were ruled out, in fact, by the GPS collar data. Okay, now we're looking at the camera trap locations between 2010 and 2016. If you look at the map, the red is the area with the highest total count. Amber were highish counts. They were in the double figures. And any of these little white spots, they're not very easy to see, but those were locations with fewer than 10 sightings, and our sample size was 333 different camera trap captures. If you look at the chi-squared analysis of cheetah camera trap observations, again it shows you preference for fine-leafed woodland. So the next factor we wanted to investigate was competitor avoidance. Chi-squared analysis of cheetah, lion and spotted hyena were plotted. Again, this shows observed and expected habitat preferences based on the camera trap observations. Unfortunately, this was actually inconclusive because all of the expected values were below 5, so it actually didn't tell us much. What was interesting was there does seem to be a trade-off between spotted hyena habitat types and cheetah habitat types. So that needs further investigation. Thank you. What she did then was she lumped together all of the competitors. So this was your lion, hyena, if I go back, lion and spotted hyena were lumped together as competitors. And again, because of the small sample size, there was no significant difference in habitat usage, and again, it was inconclusive. So here we've got plots of the GPS collar locations of 5 different collared lion prides. You can see they've all got very distinctive areas, and the home ranges plotted for each of those 5 distinct collared lion prides. And when you overlay the cheetah locations with the various lion collar locations, you can see that there is actually a spatial overlap of both the male and the female within, most of the collared lion prides in the Mfolozi section. So the shortcomings of the study is that there is a lack of long-term individual movement data from the past. We are in the process of between Ezemvelo and Wildlife Act, we're collaborating to deploy some new GPS tracking collars on the existing cheetah population, as well as the cheetah that are being introduced. There's also a lack of high resolution competitor data. So going forward, the strategy there is to make sure that any lion prides that are likely to encounter cheetah are also collared. Wild dogs need collars as well. And then we also need to deal with hyena. They're not, there aren't any immediate plans to collar hyena or anything like that, but we need to consider how we go about monitoring hyena, or a research project around hyena movements and their interactions with cheetah. Another shortcoming is that habitat structure was used rather than vegetation type. So a greater resolution for habitat utilization and preference might have been obtained by using a finer scale habitat map, a vegetation map. The conclusions: there is definitely a preference by cheetah for fine leaf woodlands. Cheetah had relatively large home ranges with significant overlap of core home ranges of the 2 collared studied individuals. So both male and the female used the same core home range. From the camera traps, there's no evidence of competitor avoidance, although this obviously needs further investigation. The sample size was quite small. But collar location data does show some avoidance at the 95% level with lions. But the long-term spatial avoidance or long-term spatial avoidance isn't supported at the core home range level. There may be temporal avoidance at play, and that hasn't been investigated in this study. So again, it needs further investigation. So with an upper estimate of 71 lions, which excludes cubs, the lion population may well be impacting on cheetah survival, especially given that we found no clear evidence of avoidance. But obviously more emphasis is also needed on understanding the impact of spotted hyena. That's it. Thank you.